a minute past 3 o'clock, and we certainly have a full agenda, so I am going to go ahead and get us started here. Thanks everybody for taking an hour out of your afternoon to participate in this workshop. We are certainly excited to be talking with you and to be sharing with you this efficient electrification toolkit that we've been working on together with the Save on Energy team to support colleges, universities, and municipalities across Ontario in their project decision making, developing new electrification projects. So with that, just welcome my co-presenters, Vicky Gagnon from the IESO and Adam Dixon from TDS Dixon. My name is Jess Burgess. I'm a senior consultant with the Canadian Institute for Energy Training. And our agenda for the afternoon, we'll have a brief introduction and a quick overview of some results that we gathered last year in some workshops and interviews we did with municipalities, colleges, and universities across the province on this topic. And then we really want to spend the bulk of our hour together this afternoon showing you what's in this toolkit. Principally these two tools, one a fairly intuitive, kind of quick back of the envelope, back of a napkin style decision tool based in Excel, and then a level 2 analysis tool using the RETScreen Clean Energy Management platform to go a little deeper. And that's really where we'll spend most of our time today, is walking you through how to use that new tool in RETScreen. Then we'd like to just have a little bit of discussion if there's time and talk about what's coming up next. With that, I will turn it over to Vicky.
Great. Thanks, and thanks for joining us, everyone. I'm Vicky Gagnon with the Independent Electricity System Operator, and I've been in the Energy Efficiency Division here for over 17 years, focusing primarily on the public sector. And as Jess said, this is a follow-up to some workshops that we held last year, as many of you are looking to electrify the heat in your buildings. And as many of you know, the IESO currently can't fund fuel switching. The switching of natural gas fueled technologies to electric end uses isn't within the current definition of energy efficiency. And that's a policy, but many of you are getting funds from the federal government or other sources. And one of the requests that we heard was for a tool to help in the decision process of where the best bang for your buck is, where to target your GHG reduction dollars to maximize your GHG savings while still managing your energy budget. And the Efficient Electrification Toolkit was developed out of those conversations. And that's what we'll be focusing on today. But first, I'm sure most of you know about the IESO, but for those of you who don't, the IESO operates the electricity grid in Ontario and plans for Ontario's future energy needs. And it enables efficient electricity markets through competition, and it enables energy efficiency across the province. Next slide. Many of you are familiar with the Save on Energy programs that offer incentives to encourage efficient use of electricity, including the retrofit program and various training opportunities. And I want to mention a few new programs that will be launching early next year. First is the Strategic Energy Management Program, which is the evolution of the Energy Manager program, and it's providing technical and training support to companies with a dedicated energy management team. And this will be in a cohort setting. Second is the existing building commissioning program to help fund a commissioning professional to help find opportunities to optimize operations and improve energy efficiency. Third is the commercial midstream lighting program with lighting incentives for lighting distributors through point of sale discounts. In addition, there are local initiatives in targeted areas of the province where the electricity constraints exist. Next slide. And with that, I'll turn it over to Jess Burgess and Adam Dixon to get into the toolkit.
Super. Thanks, Vicky. So before, as Vicky said, we are probably not at the end point, but we're not at the beginning of this work anyway. I know some of the folks here today also participated in some workshops that we did last summer just to really tee up a discussion around the topic of building electrification and understand where public sector organizations, including colleges and universities, stood in terms of their energy planning, carbon goals, and starting to develop electrification projects. And one of the things that really jumped out at me from those first couple of workshops and then a survey that we did to gather a little bit more learning afterwards was just how far along many public sector organizations were. Honestly, my bias going into it was that carbon goals were something that would probably be a driving factor looking at 2025 or 2030, and electrification projects really starting to pick up steam, 4, 5, 6 years down the road from here. But what we heard in those sessions was many of your organizations had already passed the first kind of effective carbon emissions reduction date in your plans. Those of you that hadn't, had that first date coming up in the next year or so. And nearly half of the organizations that took part in that survey, I believe there were 29 organizations that participated, had building electrification projects either completed or currently in development, which really showed us that whether, regardless of where we stand, these projects are starting to happen. And we had a lot to learn. So as a follow-up to that, to those workshops, we did in-depth interviews with a group of 11 municipalities, colleges, and universities in Ontario to try and understand a little bit better what you were seeing in conducting those projects, what some of the challenges were. And a few things stood out there, and I'll start to get into those now. But one of the things we found just as we got into this area was it can often be challenging to compare technologies and heating technologies across different fuels on an apples to apples basis, because you have so many different units involved. As we're showing here, the comparison between a combustion heating unit with gas, resistance heating, and heat pumps, all working in different units. And it was a challenge for us, even as energy professionals, to start to equate those things and compare them in a reasonable way. When we did that, here's what we found, and this was research we did for last year, so it's not quite up to date, but I think these numbers are still pretty current. The blue here represents the energy costs. The orange bar is for emissions, and the gray bar is emissions per dollar. And what we found on a cost basis, natural gas still the leader in terms of providing heat at a given price. But when we started comparing emissions, natural gas was the leading emitter there, followed by electric heat, and resistance heat, that should be labeled, with a heat pump coming in sort of in the middle, both in price and then doing very well on an emissions basis. But when we factor in the anticipated national carbon tax price in 2030, you start to get effectively to just about cost parity between that heat pump and the natural gas furnace. And again, you've still got that significant delta on the emissions side favoring heat pumps. So this, I think a lot of our logic, and probably the logic for a lot of your organizations looking at electrification projects, comes out of that comparison and that delta on the emissions side. That said, and I just want to kind of reiterate a point that Vicky made, which is the starting point for all of this really should be on improving energy performance and efficiency of your buildings before kind of moving down the decision chain towards electrifying heating loads. As we're seeing in the inverted pyramid here, there's a really significant role to improve the tightness of building envelopes and building energy performance overall in order to reduce the heating and cooling load, which will, I think, in many cases we've seen in simulations and working with real world data, allow you to reduce the size of your new equipment, likely a new heat pump, which can really improve the cost effectiveness of a project. So want to cover quickly some of the feedback that we heard from the survey and the interviews that we conducted last year, and how that led us to the toolkit that we are then going to demonstrate in just a couple of minutes. So from those, the workshops, the survey, and the interviews, I already mentioned climate targets are a near-term priority, and a lot of projects are already underway. From the colleges and universities that we spoke to, the most common building electrification project was replacing typically large, sometimes centralized natural gas boilers with electric boilers. It's a little bit different for the municipalities we spoke to, where the most common measure was replacing rooftop units with air source heat pumps. So there's a bit of a split there between the two sectors that we're primarily working with. But I think particularly notably for the boiler replacement projects, we also heard a number of colleges and universities say they had looked at the potential to replace a natural gas boiler, but they weren't able to go through with that project and add an electric boiler because of electrical service constraints, either at the building level or potentially even at the substation. And it was cost prohibitive to replace that electrical equipment that would have given them enough service capacity at their building to change out that boiler for an electric boiler. So that's a real issue that's going to need to be considered in a lot of these projects. We also heard a really important metric, in addition to things like simple payback and other financial metrics. Folks were starting to look at the cost of abated carbon as a really important metric. Essentially, how much are we paying per ton of carbon that we're abating with this project? And finally, this point that led us down the road to developing these tools that we're going to show. Everyone we talked to at the interview stage that was doing electrification projects, once they got far enough down the line into really working on that project, they engaged design engineering consultants to help them put that project together. But folks pretty consistently said at the early stage, they didn't have much in the way of tools to support early stage project identification and early development before getting to the point of engaging outside consultants. So that's where we saw an opportunity to put together this toolkit to support that early stage project decision making. So what's in the toolkit? Essentially, the toolkit is two tools. One, we think pretty fast, easy to use. I described it as like a back of an envelope calculator. Currently, what we have prepared is specifically for analyzing replacing rooftop units with all electric or hybrid air source heat pumps in Ontario. And I'll talk a little bit more about that in a moment. A second, more powerful tool includes a number of RETScreen files, pre-set up templates to facilitate users in doing a more detailed level 2 analysis of a few different types of electrification projects in any of these three facility types: small office and classroom, laboratory buildings, and fire stations. Those are the three facility templates that we've prepared at this point. And then some detailed instructions document and a checklist of the kind of data needs required to use the level 2 tool. So that's what the toolkit consists of at this point. In just a minute, I'm going to hand it over to Adam to go through the RETScreen tool in a bit more detail. But before doing that, just to say a few words about the level 1 tool. It's in Excel. The goal was to create a tool that's accessible for everybody. I think just about everybody has some basic Microsoft tools, so should be able to use this. But it's built using a few hundred RETScreen simulations. So we ran a bunch of simulations and brought it into the background of this Excel spreadsheet. So it does have some fairly sophisticated simulations behind it. But the idea of this tool is, in about 60 seconds, you've got a handful, I think 4 different variables with different permutations. You can choose whether you have just an all-electric air source heat pump or a hybrid system. You can change the fuel source of your current rooftop unit. You can change your location. There's 4 different locations within Ontario to simulate different weather environments. And then there's a variable also for energy efficiency that you might include with your project that would potentially impact the project financials, and including the sizing of your heat pump, depending on how those impact the heating load. And then you can see a number of financial metrics, as well as the cost of abated carbon, simple payback, and your overall emissions reduction from a project like that. The idea behind this tool is not to, provide a really detailed and complex simulation that lets you get into the specifics of your building and the systems that you're looking at. That's really the RET screen tool that Adam's going to talk about in a moment. The idea here was we wanted our starting point was a fact sheet that would have some basic information about what can you expect if you're changing out a rooftop unit for a heat pump, but then to allow folks to tinker around with some of the assumptions in that fact sheet to make it, to some degree match your situation and give you a sense for the likely or potential impacts that you might see from a building electrification project. Again, the idea is here is you could kind of run those different versions, different permutations of a project in 30, 45, 60 seconds, and get a quick flavor for what your impacts might look like, and then dive into that in more detail with the Level 2 RET screen tool. So with that, I'll hand it over to Adam to walk us through the more detailed tool.
Okay, just give me 1 second. Everybody see my screen there okay? Just give me a heads up just to make sure everything's sharing.
Yep.
Perfect. So
Good.
before I get started, I'm just going to mention that you're likely going to have some questions as I kind of walk through this. I feel free to type those in the chat. That's probably the best way to do it. Or if it's a very more complex question, more related to your exact situation, feel free to email one of us after the workshop. I'll try to address some of the questions as we work. If we do not have time to do that, we will address them after, and we will make sure to get back to you. So without further ado, I'm just going to dive right in. We only have about 41 minutes left, so we kind of want to make sure we get through the approach here. So basically, we use RET Screen Expert, which, if you're not familiar with, is a tool available from Natural Resources Canada. It does a variety of things. If you've come across it, it's actually a very powerful tool. It does basically benchmarking, feasibility, and performance modeling for your energy data within your building. So what we've done is, because, as Jess said, comparing these kind of things with different energy units is sometimes difficult, so it's hard to compare apples to apples, but RET Screen is very good at that with limited inputs to get you to basically 2 steps past that back of the envelope calculation that Jess had kind of mentioned with the Level 1 tool. So with relatively limited inputs, we can get not a detailed engineering calculation, but somewhere in between the back of the envelope and the detailed engineering study of your building. So hopefully in a few minutes after all of this, and you'll be able to basically maybe 15, 20 minutes, put a few pieces of data in, you can see the feasibility of switching from a gas or any other type of fuel for that matter to a air source heat pump. So with that being said, if you're unfamiliar with RET Screen, you will need a little bit of RET Screen Expert knowledge in order to use these tools. Don't worry if you don't have any now. There is lots of help out there. There's lots of information out there. We're going to use a small slice of RET Screen Expert. So if you've kind of opened the software and kind of been confused by it, don't worry. We're going to dive into very specific things on it, so you don't need to know how to use the entire software package. We'll hopefully get you to the point where you can use just a couple small sections that we use here. So to do this, we kind of divide the situation out into 2 situations. So I'll go into these in more detail. One is basically we're going to dive right into the power, heating, and cooling model of RET Screen. We're not going to use the power side. It's just labeled as that in RET Screen. So if you've used RET Screen in the past, this may be a new feature to you. So this one is where we can actually get a relative size of our heat pumps. If you've used red screen before, you've probably used on the energy side or in the feasibility model where you actually build up an entire building, where you can model switching from a gas furnace, for example, to an air source heat pump, but you do not have the ability to get the size of the heat pump. So that's where we kind of, depending on what type of data you have coming into this, we incorporate the two sides of the feasibility in red screen and pull pieces of data from one to the other in order to do the power heating cooling model, in order to size or see the feasibility of converting to an air source heat pump. So what's in the toolkit? So Jess kind of mentioned this briefly already. So there's going to be 6 red screen files you'll be able to receive. So 3 of those are an office, laboratory, and fire station in the energy model. So that's where you can have an entire building built up. These are just red screen archetype buildings. So red screen has a number of buildings built into the software. So you can use this process that I'm going to go through, and you could pick a different type of building that is in red screen as well. We just decided on these 3 to start out with, but you are not limited to that as well. The next 3 red screen files are for the same types of buildings, but those are for the power heating cooling model, or in our case, the heating and cooling model that we're going to use here. And again, we've just picked these 3 buildings. You're not limited to that. If you have more of a knowledge of red screen, you do have the ability to follow this process, hopefully, and you can do it for your exact situation. So this is just to get you started, and you can also modify these to match your situation as well. On top of that, you're going to get this overview and guidance document, as well as there is hundreds of videos out there on YouTube. That's probably the primary source of help for red screen right now, or some of the help within Red Screen Expert as well. So again, more help available to you, just to point you in that direction. I mean, even experienced red screen users, I know a lot of people we come across, they haven't really dove into this heating and cooling model, so it may be new. Using the help is very helpful in this case. So the 2 paths that we've kind of gone on this one is the whole facility. So basically, if you have data like historical data, floor data, maybe even you have your watts per square meters, we do have ways to calibrate that, as well as your heating and cooling efficiency. We can kind of skip over the first step of modeling our entire building and dive right into that heating and cooling model. And some of this data may come from a previous energy audit that you've had done, or if you know certain projects that have done in your building, as well as the historical data, you can jump right in here as well. After that, we're going to jump into that heating and cooling model, calibrate our models, see what size of system we need, whether we can go fully air source, or we still need some backup heat from our gas furnace. Perhaps we can model that situation quite easily and quickly as well. Then after that, we can go see the carbon reductions from doing our switch from the gas to heat pump. Then the next part 2, where we would actually pull up a red screen archetype, or if you have a building model already built up, we can go into there, we can model our proposed case. So that's after we've done some energy efficiency measures. We can see how much we've reduced our energy by. So as Jess kind of mentioned, you want to reduce your waste. Doing all that stuff, make sure we don't need to put in a larger heat pump than necessary if you reduce your waste. Once we do all of that stuff in the energy model, we can pull, I think it's only 3 pieces of data you need to pull out of that, and we can jump, or 4 pieces actually, sorry, we can jump over back into our heating and cooling model and follow basically the same process that we did in step 1 in order to size up our heat pump and get some carbon and financial cases on this information. So I'm going to start with method 1. Hopefully this is probably, I don't want to say simpler, but the less inputs into the data, but it's also the end goal of this is to be able to size the heat pump and see how much carbon we're reducing by. So in this case, what we want to do, so we've developed these files. All of the files are located in Toronto, just because that's where most of the population of Ontario is. But you do have the ability to move that. If you need to move your location to somewhere, say you want to model a laboratory where your university is, you can just simply go into select climate data location in red screen, which is on the location tab, and you can navigate to exactly where your building is and place it there. So it will model the weather based, or the climate, sorry, based on your location exactly. Now, once we've done that, if you're doing this from scratch, you will need to go in to the facility page, where if you've used red screen in the past, you can see you've likely used these real properties here to model your buildings. If you've done feasibility studies in red screen, we're actually going to use this power heating and cooling model, so it just changes the inputs that we're going to see on that energy tab once we get into there. Again, it says power heating and cooling. We're not doing power in this case. You can pick and choose kind of which steps or which ones you're going to actually use. So next here. So once we're in there, and like, again, these files are all built up for you and they are set up, but the instructions kind of lead you through if you could do this by yourself. So once we're in there, we want to make sure we have selected the heating and cooling. If you have the power selected, you'll have an entirely new set of inputs you will have to create, which you will likely not have data for. So the first thing we have to calibrate is our green box here. So, and there actually should be a green box kind of down here as well. So you will need to know the efficiency of your current systems here. So you have your cooling load on the top here in the green box, and then you at a COP of 3.2, and we have our seasonal efficiency of our gas furnace here at 70%. So this is kind of what we're trying to replace here. The next thing we're going to do is we want to actually calibrate this model. So we want to figure out this watts per square meter. This is the main number that is important on this. This watts per square meter here. So the cooling load for the building and the heating load for the building, watts per square meters. And I maybe need to adjust some of the boxes on here. It seems that when I've transferred over, they're off a bit. So that's kind of where we need to pull some historical data here. So basically the number here, so your total cooling energy, this 27,932 kilowatt hours, that's what we're trying to basically reconcile our model with. So we're going to use, so if you know your watts per square meter, you can put that in there. If you do not know that, you can calculate your cooling load and your heating load. It's the same thing we're going to do on the heating side. And again, if you don't know how to do that, I do have there is some guidance in a couple slides on how to actually do that. But what we want to do is we want to take this cooling load for building as well as heating load for building and kind of, I don't know, play with that number in order to get it to match your historical usage. So if you don't know anything about this and you just want to get into the ballpark to see the feasibility on this, RedScreen does offer some help for you. So if you hover over kind of the title of something in RedScreen, usually there's some contact sensitive help. So you can click on that and the RedScreen help will offer you some good help in this scenario. So if you know just a little bit about the general condition of your building, this is kind of a graph you will see. So this is for your heating design temperature. So basically, if you, and there's a note here and a couple slides that you do need to make note of the heating and cooling design temperature back on the location tab. So you can take your heating temperature, design temperature, as well as your cooling design temperature, and you can use, so say your heating design temperature is -25 and you have a medium insulation building, you can say that your watts per square meter, you would hope, will end up around 75 watts per square meter, or anywhere kind of to be in the reasonable range. It can exceed these graphs, just if you know what's going on. If it's a particularly good building or a particularly poor performing building, you can go outside of these. But if you just want to get to first base, you want to keep your range for -25 between about 65 and 85 watts per square meter here. So using the RedScreen help can get you kind of to the next step there. So once we've done that, so I've reconciled, I've figured out my watts per square meter for my heating and cooling load. I've figured out what my cooling load is for the building. So I've gone through a couple steps further from here and I figured out I have 27,000 kilowatt hours. I now see here that my total peak cooling load for the building before I do any energy efficiency measures is 16.2 kilowatts. Now, I know in my building here, you can see the next blue box or red box below, I've done some end use energy efficiency measures that have reduced my energy in this building by 50%. Now, don't worry if your building has not seen a 50% reduction in energy efficiency. These are RedScreen archetypical buildings, so they may go a little deeper than some people, the actual reality of your building. It may be in the order of 10, 15%. So don't worry if you don't see numbers of the 50% here, and on the heating side, we have 45%. So once we've added in our percent reduction here, we can see our new net peak cooling load. So this is the size of the heat pump basically that we're going to need to meet our cooling load on the top, and then that 13.9 on the bottom is our heating load as well. So I guess the one thing I forgot here on the heating side is you do need to pull out what your hot water, if your hot water is heated with gas, you do need to pull out basically your hot water load to reconcile that load. And if you're not sure how to do that, it's very similar to the pulling out what your cooling load for the building is, and I'll show you that in the next couple steps here. So once we've calibrated the model, so this is kind of the base case systems in our building, so what we have now, we can move to the next step. So this is on, if you're in that power heating cooling model, this is our load characteristics of our building, so it's still in our proposed case. So basically the only two numbers we really want to pull off of this sheet here. So this is our, again, we saw it on the previous sheet, is our 13.9 kilowatt heating load and our 8.1 peak. The key here is that is our peak load, so our peak cooling load at 8.1 kilowatts here. So I would record these numbers for further use. In my experience, when you're jumping between screens, RedScreen doesn't necessarily pull things forward for you. So kind of write this down just to make sure you have the right numbers when you get to your analysis. So if this is kind of the help on how to get your hot water percentage as well as your cooling load in your building. So you will need to get some historical data, assuming you've jumped into this model, you have that available. Best thing to do to get your monthly gas consumption or see how much gas you use for hot water is simply to sum up the gas usage from your non-heating season. So from maybe mid-April, could maybe expand this out there, but you should know kind of when your building turns off its heating systems and is just using the gas for hot water. So just sum those up for May, June, July, and August. Take that as a percentage of your total gas usage, and that's going to be that percentage you use on the previous sheet. For cooling, it's a relatively similar process. Basically, what I'm looking for is I want to subtract out the months, basically your non-cooling months, you want to subtract that usage out from your total usage for the year. So we're looking at actually trying to calculate what the usage is here, kind of under this kind of peak right here. So there is also lots of guidance. If you just Google how to do this, there's a good amount of guidance out there on YouTube or anywhere else to figure out how to do that. So now, once we've done that, we can now jump into, we're going to actually build up our proposed case system. So we want to go in there and size our system. So we go into, this is under our, it's what the title of it, just going to be, so I don't quote the wrong name. Give me one second. So this is our heating equipment. So it's a heating and cooling equipment, which is actually our proposed case. It doesn't say that here, but this is our heating and cooling equipment in RedScreen. This is now RedScreen up on the screen as well. So what we want to do, and oops, wrong one click too many. In our models, we sized the systems exactly to meet the heating and cooling load. Now, this may not exactly be the situation that you come across. It's highly likely that you're not going to find a heat pump that has, if it's something like 8.1 and 13.9, where there's a 50% difference in the capacity of heating and cooling. You may not be able to find that exact match. So you have to kind of play with these numbers on what's available to you from, there is a product database in RedScreen or from a contractor that you've talked to, get what's available to you in specific systems and kind of size it based on that. So, and once you've done that, you then need to put in those new efficiencies or coefficients of performance for the heat pump. So on our cooling side, we have our 3.2, so we're using the same coefficient of performance that we use in the base case, just because the cooling system isn't really changing or the cooling load hasn't changed from that, because we're not switching that from any other source of fuel. On the heating side, we then need to put in our seasonal efficiency. Just the way RedScreen works, it uses seasonal efficiencies for gas instead of coefficients of performance. So if you have, say, a coefficient of performance of 2 here, that's indicated as a efficiency of 200%. So that's what you would put in there. If you have higher, you can go higher than that. So the next thing we're going to do is RedScreen's telling us here, you can see those 100% on kind of the right-hand side of these dialogues. That's telling us that we're meeting all of our energy and load demands with this heat pump. That may not always be the case. That's where we can go in and we can have a peak load heating system. So what that's doing is RedScreen's telling me here that I don't actually need that peak load heating system. So, but if I did, I could select that. RedScreen then defaults to the base case system. So whatever you already had there. So if you have a relatively new gas-fired boiler or furnace and you don't necessarily want to pull the whole thing out, you want to reduce your costs up front. This is where RedScreen is very handy at playing with different scenarios in terms of sizing for cost and also in terms of sizing for carbon reductions. So we can reduce the size of our heat pump and still basically we can meet, you can play around these numbers, and it's actually quite cool how I can lower this heat pump capacity. I believe if I lower it to a 10 kilowatt system, I'm going to meet, it's only going to be, say, 80% of my capacity, but the heat delivered is actually going to be about 98% of my heat delivered. And that's because we only need that furnace, or sorry, not the furnace, we only need that extra 4 kilowatts for such a short amount of time in the year. So it's actually, we have extra capacity for a very small percentage of the time in the year. And if you're curious how Red Screen does this calculation, sorry, it's very well documented in the help in Red Screen, and at the end of this slide, there is a direction to where that is. It uses a 13-month calculation, and it's actually only about 100 hours where you would be using that extra capacity. So once we've done that, we can, and I could pull Red Screen up here maybe quickly, and I can show you how we can do this. So I can go into my heating equipment, and if I actually lower the capacity so that from 14 or 13.9 to 10, and I go and look at that system characteristics diagram now, it should change. So we can see here it's actually leaving less. So it's 72.2% of my capacity is only that much is delivered, but I get 98.1% of my heating delivered there because, again, I only need that heating load for such a short amount of time in the year to match that. And now the Red Screen then defaults to my peak load heating system being my gas-fired furnace. And I do need to add a capacity. If that's the warning that it's giving me there, I will pull that from my base case system there as well. The next thing that Red Screen allows you very handily to do this, jump around on this as well. And I might just show this in Red Screen instead of in the slides. It's kind of sometimes a little handier to see it in Red Screen. So with the carbon reduction, I'm going to switch my heat pump on the heating system because, again, the cooling system is not as the same. So I'm going to go back to my 13.9. And I'm going to go over to my emissions tab, and I'm going to see how much I've reduced my emissions by. So you can see here, I've actually reduced the emissions in this building by switching to the heat pump by 95.6%. So I'm going to write down that number. So when I go and change one number, I can then go see how that affects my carbon reduction. Let's say I want to actually I'll cut this capacity in half. So let's go say I go down to a 7 kilowatt system just to or maybe we'll just match it exactly to the cooling system. We'll do an 8.1 or an 8 kilowatt heat capacity heat pump. And we'll see here that we only have 57.7% of our capacity delivered, but we're still getting 95.7% of our heat. So that 4.3% of the time, that's when I would actually have my gas furnace come on. So in this case, we see here it's, well, I have to add my capacity on my heating load. Let's go with 8.9. I do need to add my capacity in here just to make sure I'm actually using that gas when I'm there. That's going to make more sense. So now I still have a 93.4% reduction. So only about a 2% loss by sizing down our heat pump by almost half. So I'm not going to go out and say that's going to be half of the price of a 14 kilowatt heat pump, but the price of a heat pump that's half the size is going to be drastically reduced. And I think this is particularly handy if you have a relatively new gas system in there and you want to reduce your capital costs up front. So basically in a few steps here, we've been able to go in, enter, I think, about 10 pieces of information, and we can now say, okay, these are scenarios I can play around with. I can say, do I want to go fully electric and completely remove my gas? How big of a heat pump would that require? How much would that cost? Or do I want to reduce the cost of the heat pump, keep my furnace in there, and just kind of play around with that on the feasibility and the costing on that? Now, in this tool, we do not get too much into the costing on that. I know things in this world with the price of electricity and gas, things are changing, the price of heat pumps, all that stuff. Red Screen is very adept at doing the full financial analysis on this one. So if you're curious and you're a financial person or need to do this study, I would suggest going in and exploring the finance tab in the Red Screen model. So that's going to give you more detailed financial analysis where you can also bring in the carbon tax into this as well. So that actually right now makes these projects much better switching to electrification. So let me just bring back up my slides here and see where we've at. Yeah, and this kind of goes over that, playing with those scenarios on what size of heat pump to meet your kind of greenhouse gas emissions goals, as well as probably simple paybacks or maybe more detailed finances. So method 2, so I'd say like 50% of this method is the same as method 1. We just need to do a little bit more work up front with this one. So in this case, what we're going to do is we're going to either take one of our red screen archetypes, or we could build up our own building in red screen. If you have experience in red screen, it may seem scary here up on the screen, but it's actually not bad depending on how complicated your building is. So
sorry, Adam.
Well, yeah.
Your slide back there said it, but we moved past it kind of quickly. So I just want to get you to say what would cause you to use method 2 rather than method 1. In what situation would I use method 2 rather than method 1?
If you have limited data on your building, or possibly if it's a new building and you want to play out scenarios on whether you should install gas at all, or you should go right to the heat pumps as well. That's kind of when I would use it. It's kind of depending on if you don't have data up front, basically.
Thanks.
Okay. So once we've jumped into that feasibility model, we're going to go to our include measure screen. So on there, it's all of the summary data and all the simple finances on our data. So what we're going to do is we're going to go into select here in the green box. We want to select our energy in the base case. So red screen has 2 different ways of defining energy or fuel. So they have fuel, which is what you purchase, and energy, which is at the end use. So we want to make sure we're using the energy in this case, because the difference between the two is the efficiency of our devices. So we don't want to reconcile or calibrate our power heating cooling model and get a heat pump for, say, that 20% loss in our gas furnace. So there's going to be a 20% difference if it's an 80% efficient furnace between our energy and our fuel. So just make sure you select base case. And then the 2 numbers we want to take off of there are our total heating load and our total cooling load. So this is where if you don't have historical data and you can't do those graphs, subtract things out or take percentages, red screen is very good at just giving you the heating and cooling load separate from all the other loads in your building. So we have our 53,000 approximately and 27,000 as well. So now we can make note of those numbers somewhere, move on to the next step, which is that is going to be going to our comparison screen on the feasibility model. So then we need to figure out what percentage of our fuel we saved with our energy efficiency measures. So in this case, we want to use our fuel consumption just so we can see what the maximum reduction we had was. So here this is where in method 1, we saw the 45.6 and that 49.6 or 50%. This is where those numbers came from. In method 1, you would hopefully pull that from an audit report, or in method 2, you pull it right from red screen there. So those are the 4 pieces of numbers we then need to go over and bring into our power heating cooling model. So once we have that, we go back over into the power heating cooling model, and we've kind of gone over this. So we want to make sure we reconcile our numbers against that 27,000 and 53,000 again by adjusting those watts per square meters within a reasonable range based on the building you have or based on the archetypes that are there as well. So I'm not going to spend too much time going over this model again. I'll kind of say, so we go over there, we calibrate, we pull over that 13.9, 8.1. We now then can go to our proposed case. Again, these steps are exactly the same as method 1. It's just that bit up front to get those 4 pieces of data. And again, if your building type is not there, I think there's over 100 archetypes in there now. You can go over and look at those ones, pull those 4 pieces of information and do the same thing just to get to first base. Again, those buildings may be drastically different than yours, but it's going to say, oh, is this feasible given my climate, which is the important part when it comes to switching from gas to electricity for heating. And then we need to find our peak load heating system if necessary, or if we've decided to go with something like that. So, and this is the same as the first part where we can play around with those emissions reductions with the sizing of our heat pump. So again, if you're wondering about that whole sizing situation, because it's not really a linear drop off of what percentage of your heating load is not delivered as you go down in half. If you go into the help section of the engineering e-textbook in section 2.1 and 2.2, it outlines that in great detail, how they come up with that calculation, just so you know what's kind of going on in the background. So that's kind of an end run on how to do one of these feasibility studies or switches. So is there any questions so far that I haven't seen or have come up in the chat today?
We haven't gotten questions in the chat. I will have questions. I'll have questions for others. But I do want to leave time for anyone who has had a question about what Adam covered. Maybe while you think about your questions, and if you have a question, please either type it in the chat or you can use the little reaction button and raise your hand, and I'll open up your mic. But I'll say we know from having built these tools that there's absolutely some complexity involved here. It's not the most straightforward thing. RedScreen is a very powerful platform that can do a lot of different types of analyses. And Adam, when we built these templates in order to kind of put some structure, some guardrails to sort of help channel you into the types of analyses that we think are most productive here. But it's not the most simple and straightforward thing in the world. So I do just want to say one thing that I neglected to say earlier. We will share the toolkit, all of both the tools, the instruction set, the checklist with all of you after this session. So you'll all get your hands on the tools yourselves. But in addition to that, we're going to, this session's being recorded. We'll make the video recording available if you want to go back and listen to Adam's explanation of any of the steps. But we're also aware that there may need to be kind of further support down the road in helping, especially once the first 1 or 2 times that you use the tools. As we've used them more and more, we found that, as with some practice, you can do an analysis like this in 10 minutes, 15 minutes. And the idea is if you're looking at a portfolio of buildings and 5 or 10 potential projects, this is where the RedScreen tool would be really handy to take an hour or two, run some simulations across all of those buildings and see where your cost and your carbon impacts kind of have where you have the Goldilocks there. And also, Paul, I saw your question. We'll come to it in just a second. I'll just say, so that was the use case that we principally had in mind in building this. Then we worked with 3 beta testers at different municipalities in Ontario this spring, and with real buildings and projects that they brought to us. And we found another use case in one of those beta testers had a project that they were working with some design engineers currently, and they found the ability to play with the sizing and see that, if they changed the size of those heat pumps, what impact that would have on the overall project cost and on their carbon reduction was really helpful in informing some different scenarios that they then brought up to discuss with their consultants. So there have been a few different use cases that have come up throughout. Let's see. Now let's go to Paul's question.
Yeah. So just before I address Paul's question, I'm going to say I didn't really mention this up front. If you do not have a license to RedScreen, it's highly likely that somebody in your organization does, and you will have access to it. If you're all through universities, you should have access to a RedScreen license. But also you can go through and do these tools for free. You can download RedScreen Expert. The viewer mode allows you to do all of these things. You just won't be able to save or export your files. So there's workarounds to do it, but all of you should have access to RedScreen Expert or a license of some sort. And again, if you're wanting to do this for your exact situation, I would highly recommend using these templates first to familiarize with it. If you're not familiar with these models already, work through them a few times, maybe start from scratch, take those numbers, see if you can build it up and then match it to our models. Then go in and try and do it with your building. So, and Paul, your question, so the mixed use, so in our example, so the mixed use, the furnace or the gas-fired furnace, that would be for the full load. That's simply because that was there already. You're not going to alter the current system. You leave in your current systems, you only use for those peak days. If you were to install a brand new hybrid system, for example, then you may want to install the gas furnace would be the difference in capacity. So you don't want to put in a 14 kilowatt gas furnace. You would put in the smaller one just to maybe reduce your upfront costs. Does that make sense, or does that answer the question?
And I'll say 2 things. There's a follow-up question there about, is it air source heat pump only or water source heat pumps. But I'll also say, Paul, I opened up your mic, or I gave you mic control if you want. So if you want to add it, add anything to your question, feel free to jump in.
So red screen can do it for other types of heat pumps. We've just kept it to the kind of the simplest one possible. Again, if you want to dive into that in more detail, feel free to reach out to us, and we can kind of help you along that way. It does do other things. It does ground source heat pumps, all sorts of things like that. And the models do work for other types of fuels. David had a question. So you can, it's a pretty simple selector in there in red screen. If you go into your energy, you can select, well, even this is on our peak load heating system. I don't have to use my existing system. I can change it to whatever fuels I've defined here. So if I have oil, I can use oil here as well. If I have any number of fuels, Red Screen has a very extensive list of different fuels. So you're not limited to natural gas. It can switch from propane, from oil, all those sorts of things. So we just, again, use natural gas. That's the most common one we come across in Ontario or in the urban areas in Ontario. So, but you can do other things as well.
Great. I will say, so Red Screen is very flexible and powerful, can do a lot of different things. We did, like we said, put some guardrails on the templates, but then for the Excel-based tool, the much simpler tool, that one has a much more constrained kind of parameter set. So the options there for the existing system are the rooftop unit is either natural gas fired or propane fired, and either an air source heat pump or an air source heat pump with a backup heating system. So the systems are constrained to just those options currently in the simpler Excel-based tool. I would, if others have questions, feel free to throw them in the chat, but I would appreciate the chance to get a bit of feedback from all of you while we have you here. And I guess my first question, acknowledging the kind of inherent complexity in the level 2 red screen-based tool, I'm curious, one thing we heard in the workshops and then the follow-up interviews last year, most of the folks we talked to had Red Screen licenses and had used Red Screen at least somewhat in their careers. But I'm just curious, folks on the phone, would those of you who have used Red Screen have some amount of Red Screen familiarity? Just indicate that in the chat. You could just type a yes or a me or anything helpful. I'm just curious, of the 25 folks we have here, how many have done some work in Red Screen?
Even if you've done mostly work on the performance side, that tends to be where a lot of people work. Just knowing how to navigate in Red Screen is a large help in doing these as well.
Yeah. Okay. Looks like maybe half, maybe not quite. Okay, that's helpful for us to know in thinking about what types of support and how much support might be needed. Great. Yeah. To support these tools down the road. I'm also curious, so for the Red Screen tool, we have the 3 different facility templates: an office classroom building, a laboratory building, and a fire station. Are there other types of facilities that you're really interested in seeing because you're either actively working on electrification projects in those facilities, or you have plans down the road or have particular potential in certain types of facilities within your portfolio? For example, we did a similar session as this one a couple of weeks ago for municipalities, and a whole bunch of folks raised their hand and said, we're really interested in multi-use recreational centers. So we very much took note of that. So similar feedback would be really helpful from all of you. And I see Chris said athletic facilities with pools. Great.
I was going to say that's likely based on the municipality is going to be one.
Okay, I'm just going to put a last slide up here really quick. Great. Thanks everybody for sharing that feedback. That's really helpful for us. Before we wrap up, I just want to acknowledge everybody who has been involved in this work so far. So everybody on this list was involved either beta testing these tools earlier this year, helping us work out the kinks, and especially helping us put together the instructions and see where people really needed more guidance in how to use them, as well as those who took part in the detailed interviews with us last fall. And then just to say again, the recording from this session and all the materials, including the instructions and the complete toolkit, will be shared with everybody by email within the next 24 hours. Adam has graciously offered, if you try out the RetScreen tool and run into questions or challenges in the next couple of days, you can reach out with those questions. And finally, we would really appreciate your help just giving us a little more feedback by responding to a very short, probably 2 to 3 minute survey about this session, and then about additional support that you'd like to see for your energy efficiency and electrification projects going forward. So I just dropped a link to that survey in the chat. It should only take about 2 minutes, and your feedback there will be very helpful to us. Thanks everybody for dropping those facility type suggestions into the chat. That's really great. In our last minute or two, are there any final questions? Great, then I'll call it here. Thanks everyone for sharing your time and attention with us. Thank you a lot, Adam, for guiding us through using the RetScreen tool. Thanks, Vicky. And we have a couple of minutes here. Everybody go do that survey and have a great rest of your afternoon.